Math 106, Module 6.7. In this lecture video, let's take a look at the concept of Pythagorean Theorem. You may have learned this back when you were in high school. All right. So Pythagorean Theorem is really about finding the sides. For what we're doing right now, it's about finding the sides of a right triangle. All right. So normally, when I have a right triangle, okay, any kind of triangle always gonna have a base and the height. Okay, so we know this is a right triangle because 90-degree angle. Now, when we put our right triangle, okay, and begin to talk about in terms of Pythagorean theorem, okay, the longest side we call them the hypotenuse, and the hypotenuse, that side is always across from the 90-degree angle. Because if I have a right triangle with one angle being 90 degrees, that means the other two together will be 90 degrees. Therefore, it makes the 90-degree angle as the largest angle inside the triangle. So if the 90-degree angle is the largest angle, then across from it, that side, which is called a hypotenuse, must be the longest side out of the three. Okay? So the sides and the angle that's opposite to it actually has a very close relationship. Okay? They are actually corresponding to each other. All right? The bigger the angle, all right, then the side that's opposite to it is going to be longer. All right? So when we talk about Pythagorean theorem, we have the longest side being the hypotenuse, which is always located across from 90 degrees. The other two sides, we don't call them base and height. We just simply call them legs. Okay. So, as you can recall, Pythagorean theorem says a squared plus b squared is equal to c squared. So the side c is always going to be indicated as for the hypotenuse. Hypotenuse is always going to be abbreviated for the letter C. The two legs, we just call them A and B. So exactly what this formula is saying is A squared, side A squared. When you say the word square, that means you're literally going to have a square. Geometrically, what you have is a square. Okay? Algebraically, square means time itself 2 times. Geometrically, when you say the word square, it means you have a square. And for module 5, when we say the word square, we also referring to geometrically as areas. So that means, let me go to the next page, okay? Same picture, I'm gonna go to the next page. So basically, what Pythagorean theorem, that formula is basically saying. Draw a right triangle. Let me rotate this real quick. All right, so not quite like it, but it's close enough. All right, this is C, right? This was A, then this is B. So basically, when the formulas say C squared or A squared, doesn't matter. I'm going to just say C squared first. Sometimes I say C squared first. Sometimes I say A squared plus B squared first. So that means C squared. So that means there is a square, okay, using the side C. So this square, I might not draw it perfectly. This square, the area of this square is going to equal to the area of this side A squared, which is the area, plus the area of using side B as being a square. So C squared plus A squared, C squared equal to A squared plus B squared means the area, okay, of this square is going to equal to the area of this square plus this square, okay, because all three square is using side C, okay, side A and side B, okay, because it's B by B or A by A and C by C. Okay, so the whole entire Pythagorean theorem is referring to the area, okay, of these squares that I'm drawing here. Okay, that's what the formula actually representing. So we use Pythagorean theorem to basically finding the length of the sides, okay, that is missing. So for example, let A and B be the length of the legs and C be the length of the hypotenuse of the right angle. Use the Pythagorean theorem to find the length of the side that is not given. So I'm looking for side C here. A is 12, B down here is 5. So by using Pythagorean theorem, and I hope you don't mind, I like to say A squared plus B squared equal to C squared. So my side A squared, that will be 12 squared, plus B squared, which is 5 squared, equal to my side C squared. All right, so most of y'all probably know this is 144 plus 25, but I'm going to type it in, okay? All right, so as far as square concerned, when you key in the calculator, there's a square button here I can use, or I can use a caret key and then say raised to the second power, give you the same thing. So this is going to be C squared equal to 169. So to get my side C by itself, I got to use its opposite operation, which means I got to take a square root on both sides. So when square and square root cancels out, I get side C is equal to 13. Square root of 169 is 13. There you go. Now, in Module 16 of Math 108, when we take a square root on both sides, the answer is supposed to be positive or negative. The reason why I'm not mentioning negative because I cannot have a negative side. So so whatever side I'm looking for, I'm only going to use the positive answer. Okay, can't have a negative dimension on a geometric shape. All right, this is finding side C again, which is hypotenuse, which you notice is always across from the 90-degree angle. So let's try this again. A squared, which is 10 squared, plus my B squared, which is 2 squared, equal to the C squared. So 10 squared is 100 plus 4 is 104 equal to C squared. Round your answer to 3 decimal place. So now when I take a square root on both sides, so I'm taking a square root of a number that is not perfect square, so I'm going to end up with some sort of decimal. So I need to round to 3 decimal places, so that would be square root of 104. 3 decimal places, that will be 10.198. Okay, that's all it is to it. That's how we use Pythagorean theorem to find the missing side of a right triangle. All right, let's try some application problem. If an airplane directly over your head and altitude of 8 kilometers, so this is me, okay, 8 feet above, there's an airplane, there you go, little wing, there you go. All right. How far is the airplane from your position after it has flown 15 meters? Okay, so if I've flown 15 kilometers, sorry, not feet, kilometers, km. So how far is it from me? So airplane goes straight 15 kilometers. It was 8 kilometers above me, then it fly 8 kilometers past me. So how far is from my current location? So for my current location, this side right here got to be referring to as the hypotenuse. Okay, because this creates 90 degrees directly above me and then fly straight 15, that creates a 90-degree angle here. So I'm basically looking for the hypotenuse, which is side C. All right, so A squared plus B squared equal to C squared. So the two legs, A and B, don't matter who is A, who is B, okay? So let's say A is the 15, how about that? Squared plus my B, which is 8 kilometers squared, equal to C squared. Let me punch this in, let's see what it is. So 15 squared plus 8 squared, all right, is 289. So my C squared equal to 289. Now take a square root on both sides. My answer, C equals, let's see, round, I don't know if it's a perfect square number or not. I never memorized anything past 15 squared, so I don't know. Oh, 17. So that's exactly 17 kilometers away from my position. All right, let's try this one. The bottom of a letter, so here's a letter, is placed 8 feet from the tree. Okay, so here's a letter is placed 8 feet. So let's say this is 8 feet from a tree. If the letter is 17 feet tall, so let me make my letter a little bit taller, okay? All right, so here's my little tree. The bottom of the letter is 8 feet from the tree. If the letter is 17 feet tall, what is the height of the tallest branch of the tree? So the height of the taller, excuse me. So let's just pretend there's let's put it right here, okay? Let's say right here is the tallest branch, okay? All right, how far is that distance, okay? Since the distance from the tree to the letter is 8 feet, that means from here to here must also be 8 feet. So I'm basically moved this 8 feet down here, this line down here upward, all right? So if I draw a straight line from the branch to my letter, that creates my 90-degree angle. All right, what is the height of the tallest branch, okay? All right, so either way, what is the height of the tallest branch in the tree that the letter can reach? Okay. Well, let's see. So basically, in a way, it's asking me the height. In a way, it's kind of asking me the height of the tree then. Bottom of the letter is placed 8 feet from the tree. Oh, I'm sorry. My drawing is wrong. Let me redraw this. I'm thinking about the wrong way. Sorry about that. All right, so I think what the problem is saying is, all right, the bottom of the, so let's say here is a tree, right? Here is a tree, okay? So 8 feet away, okay, I have a letter, so my letter is actually leaning this way, okay? So if the letter itself is 17 feet long, I draw my letter upward, I should draw it leaning towards a tree. The bottom of the foot right here is 8 feet away from the bottom of the tree. So what is the height of the tallest branch? So let's pretend taller branch is right here. This problem is looking for the height of my tree, the tallest branch. So that means the 17 feet becomes my hypotenuse, which is size C. The 8 feet down here is one of my legs. So let's just call this leg down here, 8 feet, to be A. So that means I must be looking for the other leg, B. All right, so A squared plus B squared equal to C squared. Hypotenuse is 17 squared, set it equal to A squared plus my missing leg, or the height of the branch here, B squared. All right, so let's do a little bit of algebra. I know we have not formally introduced algebra yet, but let's just do a little bit right here. So let me, I know 8 squared is 64, plus my B squared is 17 squared. Let's see, 17 squared, 289 right here. So I mentioned the wording term before. So here is an addition sign outside the parenthesis. So that's separate between two terms. In Math 108, I will introduce this a little bit better, how to solve linear equation. So I want my b squared to be by itself. So this positive 64 need to actually be moved over to the other side. So that actually become subtracting 64 on both sides, which also, or you can say move over become negative 64. So let's see, if I take 289 minus 64, I get 225. So to get my side b by itself, take a square root on both sides. Since square and square root will cancel out, that means this height, okay, that means this height, the height of the tallest branch must be square root of 225, which is, I'm going to show you this real quick, square root, right? If I don't want to type in 225, okay, I'm gonna be a little bit lazy here. I'm gonna say second A and S. A and S stand for answer from the previous line. So I'm taking the square root of the answer from the previous line, which is 15. Okay, sometimes that kind of saves us time to enter it. So that means my side B is 15 feet tall. All right, so in this lecture video, we take a look, we explain what the Pythagorean theorem is, okay, what they really mean, and we did some application using Pythagorean theorem, which we use, but normally we use Pythagorean theorem to find the missing side of a right triangle. All right, that will conclude this lecture video. Thank you for watching.